In today's lesson, we are going to be looking at factoring. So this entire lesson should be a review from grade 10 and grade 11, where you should have previously looked at factoring. And essentially, factoring is the opposite of expanding or using the distributive property or the FOIL method. Now, there are 5 different types of factoring that you may kind of come across. We're kind of going to look in the order from what you should start looking for first, and then work your way through to the different levels. Some are easier than others because some you're looking for patterns, with the 5th one, complex trinomials, being kind of the more difficult one. So first is common factoring. So essentially with common factoring, you are looking to see, is there a number or variable that is common in both terms, right? Or is there a factor, right? And by factor, we just kind of mean, is there a number that multiplies to what we're looking at? So if I were to look at the first one, 7x minus 14, right, I'm going to look at each term, right? I don't see an x in each term, so the variable or the x is not a common factor. So if I look at 7 and 14, I want to think, what are the factors of 7 and 14? Or basically, what are the numbers that multiply to give me 7 and multiply to give me 14, or negative 14? Right, so if I look at this, I'll do this. So 7 can be broken down into 7 and 1. Those are the only 2 factors of 7. For 14, we have 14 and 1. And we have 7 and 2. So we see that the greatest common factor between these two numbers is 7. So that means that I can take a 7 out of each, or I can basically divide each term by 7. So we do that, the factor, or the greatest common factor, comes outside. We divide each term by that. So 7x divided by 7 is x. Negative 14 divided by 7 is negative 2. You could also think of it as 7 times what gives me 7x? Well, x. 7 times what gives me negative 14? We have negative 2. So this is my factored form. I can't factor 7 any further, and I can't factor x minus 2 any further. 2, same idea. We're going to look between all 3 terms and see what is the greatest common factor. When we're looking at numbers, 2, 4, and 8, well, the greatest number that can multiply into all of those is 2, right? Because 2, the first one, 2 times 1, those are the only factors. Then 2 also goes into 4 and 8. So 2 is our greatest common factor, or at least the number. We see that each term has an m and a t. So that means m and t will be our greatest common, or will be a part of our common factor. We just need to think about, okay, what exponent is going to be on m and t. And when you're factoring, you're going to go with the lowest or the smallest exponent that we see. So if I look at m, I see that there's an exponent of 1, 2, and 1. So that means m to the power of 1 is going to be the smallest factor that I take out for m. And for t, I see squared, cubed, and to the power of 5. So that means squared is going to be the smallest number, or the smallest variable that comes out, so t squared. So 2m t squared is our lowest or greatest common factor. So now I'm going to look, okay, 2m t squared times what gives me the first term? Well, because it's the exact same thing, I'm going to put a 1 there. There needs to be a placeholder if it's the exact same thing, because 1 times tm squared, 1 times 2mt squared gives me the same thing. Look at the next term. Instead of the 4, we're going to have a negative 2, because 2 times negative 2 is 4. We're going to have an m, because m times m is m squared. And we're also going to have a t, because t squared times t is t cubed. And for our final term, 2 times 4 is 8. M, we don't need to put anything down because it's the same term variable, m and m. And then for t, we're going to have t to the power of 3, because t squared times t to the power of 3 is t to the power of 5. And that is my factored form. I can't factor it any further. If I look at 3, again, it's going to be very similar, same idea. I have 12, 16, and 8 for my numbers. The lowest, or the greatest common factor for all 3 is going to be 4. because 4 goes into all three numbers. Each term has an x and a y, so I am going to have an x and a y. The lowest exponent on the x is 2, and the lowest exponent on the y is 2. So that's what my exponents are going to be in my greatest common factor. So now let's start looking at what the inside, or what would remain if I remove this factor. Well, 4 times 3 is 12. X times x squared is x cubed, and I don't need to put any y's because y squared is what I want to get. So I would just carry the y squared over when I multiply, or when I expand. 4 times negative 4 is negative 16. X squared times 1 is x squared, so I don't need to put anything. Y squared times y cubed is y to the power of 5. And for our final term, 4 times 2 is 8. X cubed times x squared is x to the power of 5. And y to the power of 5 times y squared is y to the power of 7. So that is my expanded form, or factored form. If you want to check your work, you can always go through and expand this similar to we did in the previous lesson, and you should work your way back to where we started. In 4 is a little different. We have two terms, 3x times 2x plus 1 minus 5x times 2x plus 1. Right, so this one is a different example, because here what we're taking out as a common factor is this entire bracket. So in some cases you may have entire brackets that you can take out. So here the greatest common factor is going to be 2x plus 1. And then what we're going to multiply that is by whatever remains, which in this case is the 3x minus 5x. So that would be the greatest, or that would be the factored form. And again, you could even work backwards a bit even further. You could work backwards, and you could simplify this a bit. 2x plus 1 times 2x, or negative 2x. Right, so just simplifying that a little bit further based on what we know. That's common factoring, right? So you're just looking for the greatest common factor, and you're just factoring that, removing that from the terms, and then basically you could divide each of your terms by that greatest common factor, or see what would you multiply that greatest common factor by to get to the term that we wanted. So different ways you can think of it. We're going to move into our special quadratics. So special quadratics, the first one we're going to look at is a difference of squares. And there are some characteristics for a difference of squares. First, there are only two terms. Secondly, both terms are perfect squares. So what do we mean by perfect squares? Well, if we're looking at a number, if we take the square root of a number, and or the exponent is even. Right, so either we can take the square root of the number nicely, or not of a number, of the number. So if we can take the square root of the number, that means it's a perfect square. And or if the exponent on the variable is even, that also means it's a perfect square. And we'll look at examples of that. The other thing we want to look for is that there's subtraction. So two terms, both terms are perfect squares, and we're subtracting them. So if I look at the first one, x squared minus 4. Well, the x squared, that is an even exponent, so that is good. And 4, if I can take the square root of 4, I get 2, so that is good. So when I'm factoring a difference of squares, there's going to be two brackets. One is going to be plus and one is going to be minus. That's always going to be the case. The first term in each bracket is going to be the square root of the first term, which in this case, the square root of x squared is x. or essentially you're dividing that exponent by 2. So we have x in the first term, and then the second term is going to be the square root of the second term in your expanded form, or in this case, the square root of 4, which in this case is 2. So we have x plus 2 times x minus 2. That's your factored form. If I look at 2, I'm going to go through and check. Square root of 25 is 5, so that's good. We have an even exponent, that's good. We have subtraction, which is good. And if I take the square root of 16, that gives me 4, so that's good. So I have everything that I'm looking for. This is a difference of squares. So now I can figure out what my two terms are. One's going to be plus, one's going to be minus, or my two brackets, sorry. One's plus, one's minus. Square root of the first term. Well, square root of 25 is 5. Square root of x squared is x. Square root of 16 is 4. So I have 5x plus 4 and 5x minus 4. And that's all we have to do. 3, same idea. Let's check. There are two terms, there's subtraction. I can take the square root of 100, that is 10. I can take the square root of 9, that is 3. And a to the power of 4, so an even exponent, so that's good. So let's come up with our two brackets. One's plus, one's minus. Square root of 100 is 10. Square root of 9a to the power of 4 is 3a squared. So when you have an exponent, if it's an even exponent, when you square root it, just divide the exponent by 2. Now you might ask, does it matter if the plus comes first or the minus comes first? It does not. I can switch these two around. I can put the minus first and then the plus. Either way is fine. For number 4, we have two terms. We have a addition, not a subtraction. So even though square root of 64 is 8, square root of 49 is 7, x squared is an even exponent, even though that all works, right? Because the sign is addition, we cannot factor. Right, so you cannot factor by difference of squares. So cannot factor as a difference of squares. D of s. What we could do though, well, nope, we couldn't even do that because I'm just thinking, is there a greatest common factor between these two terms? I don't believe that there is, so we cannot factor this any further. For the next type of quadratic or kind of special cases, we're going to look at what we call perfect squares. So this is going to be a little bit similar to the difference of squares in terms of we're looking for some specific scenarios first to see if it's kind of fits our pattern or what we're looking at. So perfect squares, there's 3 terms. The first and last terms are perfect squares. And then for the middle term, if I take the square root of the first term and the square root of the last term, multiply them together, and then multiply by 2, do we get the middle term? So I know it's kind of a long, kind of winded thing that we're looking for, but we'll look through it and I'll show you what I mean by that. So first things first, 3 terms, good. Right, so there are 3 terms. Let's take a look at the first term. Can I take the square root of x squared? It is an even exponent, right? So that works, it's x. What about the last term? 9. Well, square root of 9 is 3. The middle term, if I take 3 times x times 2. So 3 times x times 2. Do I get the middle term? I do get 6x, so that works as well. We're not concerned about the sign. So if this was a minus 6x, that's okay. We're not concerned about that. We're just concerned about the number and variable itself. So all of that works. So what we do next is we're going to have one bracket. It's going to be squared because it's a perfect square. The first term is first, x. 3 is our last term. And the only thing that's going to be different, the only thing we want to make sure is the sign is going to be whatever the sign is between the first two terms. So in this case, addition. And that's our factored form. You could also rewrite this as x plus 3 times x plus 3, but because it's multiplied by the same thing, I can just square it instead, which is where we get the term perfect square. Let's look at number 2. Take the square root of the first term, 9x squared. That gives me 3x, so that works. Take the square root of the last term, square root of 16. I get 4. That works. If I do 3x times 4 times 2, I get 24x. That works out to my middle term. That works. So now I can set up my one bracket. It's going to be squared. I'm going to have 3x. I'm going to have 4. The sign in between is going to be addition because it's addition between the first two terms. Let's look at 2 more examples, then we'll move into our simple trinomials. So, same idea. 3 terms, good. Let's go through and check the first and last term. Can we take the square root of them? I get 3x is the square root of 9x squared, so that works. 1 works as well because the square root of 1 is 1. So if I do 3x times 1 times 2, 3 times 1 is 3, times 2 is 6, carry the x, I get 6x, which is the middle term. So this is a perfect square trinomial. I'm going to set up my brackets. It's going to be squared. The first term is the square root of my first term in my trinomial, so 3x. Last term is going to be 1. And the sign in front is now going to be a negative or a minus this time because of the sign in the minus x. Or the minus in between the first two terms. In the last example, same idea. 3 terms, good. Let's check if it fits the characteristics. So if I take the square root of 16x squared, I get 4x, so that works. If I take the square root of negative 4, I can't take the square root of negative 4. So this does not work. So because we cannot take the square root of a negative 4, that means we cannot factor as a perfect square. In this case, we could work through it and factor it as with common factoring because we should see, well, there is a common factor of 4. So I can take out a common factor of 4. I get 4x squared plus 4x minus 1. And I can't factor that any further. So I could common factor this, but I couldn't factor it as a perfect square because of that last term not being a perfect square. Next example is going to be our simple trinomials. So this is one that's going to require a little bit more work than some of our other ones. The other ones we were looking for characteristics and just kind of plugging them in. This is going to require a little bit more work. Right? So the idea of simple trinomials is you have 3 terms. And the key thing is there is no number in front of the first term. So what I mean by that, if I look in front of this x and if I look in front of all of these ones, there is no number. There is a number in number 4. We do see a 3. We're going to touch on that when we get to it. But looking at all of these, there are no numbers in front, so that's a simple trinomial. Right? So you'd want to see, yeah. So what we're going to do then is we're going to focus on the 2 other numbers. And this is where we call the product and sum. Product means 2 numbers multiply, and sum means two numbers are adding, or product is multiplication, sum is addition. So what we're doing is we're looking for two numbers that multiply to give us 30, and the same two numbers add to give us 11. So we have to look for two numbers. I'm going to suggest whenever you're doing this, always look for the numbers that multiply to give you 30. Right? Or always look for the numbers that you're multiplying because there's less options. So for 30, we have 30 times 1, but 30 plus 1 does not equal 11. We have 2 times 15. 2 plus 15 does not equal 11. We have 3 times 10. 3 times 10 does not equal, or 3 plus 10 does not equal 11. There's nothing with 4. For 5, we do have 5 times 6. Oh, and 5 plus 6 is 11. So these are our two numbers. Because 5 times 6 is 30. 5 plus 6 is 11. So once we find those two numbers, we're going to create two brackets. The first bracket, or the first term, is going to be the square root of what our first term is. So in this case, the x squared, or the x from the x squared. And the second term is just going to be the two numbers that we found. So in this case, it'll be a plus 5 and a plus 6. So x plus 5 times x plus 6 are the two numbers that would go in, and this is our factored form. So a little bit more work, right? This is where knowing your times table is really helpful because it helps you kind of think of those numbers quickly. So you might not have to write them all down or go through all those steps. You might just be able to pick out the numbers right away. For the next one, right? So the product, two numbers that multiply to give us 20, and they must add to give us -9. So this one's a little bit more challenging. So because we have to add to a negative number but multiply to a positive, chances are both of our numbers are going to be negative. That's the only scenario that will really work. So let's go through. So -20 times -1, nope. -10 times -2, nope. That doesn't work. 3 doesn't work. -4 times -5, ooh, that does work. Right? Because -4 times -5 is 20. -4 plus -5 is -9. So that means then our two numbers, or our factored form, would be x minus 4 times x minus 5. And again, if you're unsure, you can go back and multiply, expand these two brackets, right? Multiply these two brackets together, and you should get back to that original term, or that original trinomial. Next one, x squared minus 7x minus 18. Again, so we're looking for two numbers that multiply to give us -18. Two numbers that add to give us -7. Because we're multiplying to a negative, one has to be positive, one has to be negative. So let's go through. 18 and 1, or 18 and -1. Nope, that won't add. 9 times -2. Now this gives me 7. I want -7. So if you find that it gives you the right number but the wrong sign, just switch the signs. Make this a -9 and a +2. It still multiplies. And now when you add them, it works out to a -7. So we have -9 times 2 is -18. -9 plus 2 is -7. So I found my two numbers. So when I factor, it's going to be x minus 9 times x plus 2. Again, the order doesn't matter. right? You could have the +2 first and the -9 or the -9 second. It doesn't matter. Now for 4 4 is a little different. We did say, well, a simple trinomial does not have a number in front of the first term. That is true, right? We do have this 3 here. However, if we look at our hierarchy of kind of what we should look for in terms of factoring, the very first thing that was on there was common factoring. So I'm going to common factor first, right? Because if I look, I should see that 3 is a common factor between all 3 of these. So I can make it x squared plus 5x and then minus 12. I believe. Just double check that. Nope, not 12. So -14. So now I can look, or now that I see that in the brackets I have a simple trinomial. So now I can go through, look for my product. So 2 numbers that multiply to give me -14, and 2 numbers that add for the sum of 5. So again, because they're multiplying to a negative number, one should be positive, one should be negative. So let's start going through. So 14 times -1, that doesn't work. We have 7 times -2. Wait, that does work. Because 7 times -2 is -14. 7 plus -2 is -5. Or sorry, is +5. So now I'm going to leave the 3. I'm going to break this trinomial up into 2 brackets. I'm going to have x as the first term in both. One will be +7 and one will be -2. And that's our factored form. So in all of these ones that we've looked at, you may have to common factor. Right? You might have to common factor some of these trinomials first, and then it might work into these different forms. Lastly, we have complex trinomials. These ones are a little bit more challenging because there's a little bit more to it in terms of what we have to do to find out what the factored form is. So there's different ways that we could do it. I'm going to show you kind of 2 different ways. First, what we're going to do is we have, again, complex trinomial, right? We have a number in front of the first term, right? So if you want description number in front of the first term, right? If we look at all these, there's a 6, there's a 2, there's a 6, a 4, a 3, a 15, right? Numbers in front of those first terms and all of them. You could look to see if we can common factor, but if we look at the first one, 6x squared plus 17x plus 5 does not work. Right? So we cannot do that. That will not work. We cannot common factor. So we have to factor this as a complex trinomial. There's 2 different ways we could do it. First way, this is kind of a different way that you might have learned. You're going to be looking at the first and the last number, the 6 and the 5. With the first number, what you're going to do is you are going to write out the factors. So first we have 1 times 6, 2 times 3, and that's it. What we're going to do also, though, is reverse those 2 numbers. So rewrite these same factors, but flip them. 6 and 1, 3 and 2. We're then going to draw a line. And we're going to look at the second term, 5. Right? So we're going to start with the smaller number on top. So 1 and 5. That's it. There are no other factors, but we're not going to flip the second one. So what we're going to do next we're going to do some cross multiplication, and we're going to check to see if when we cross multiply, do the numbers add to this middle one here, 17. So let's try. So 1 times 5 and 6 times 1. So 1 times 5 is 5. And 6 times 1 is 6. So that does not work. So let's try two other numbers. Oops. A little bit hard. Keep erasing. So let's try two other numbers. So now we move 1 over each. Right? 2 times 5 and 3 times 1. So 2 times 5 is 10. 3 and 1 is 3. That's 13. That does not work. Oops. I have to figure out a different way. It's going to be a little bit messy if I have to keep on erasing these every time. So that doesn't work. So let's move over again. So 6 times 5, 1 times 1. 6 times 5 is 30. 1 times 1 is 1. That does not work. So then we move over again. 3 times 5, 2 times 1. We have 15 plus 2. Okay, that works. Because that gives us 17. So now we found our pair of numbers. So now what we're going to do, we're going to take the top two numbers, and we're going to take the bottom two numbers, and those are going to be the two numbers that go into our brackets. Now the numbers on top, the first two numbers, these are going to be the numbers that go with our x, or the first term. The second two numbers are going to be the ones that go in our second one. So we have 3x in our first bracket, 2x in our second bracket, then plus 1, and then plus 5. And that's our factored form. Let's try that example with a different one. Let's try that with the next one, just so we can kind of get used to this new style. So it's a complex trinomial. I'm going to write out the factors for the first term, draw a line, and then write out the factors for a second term. So for the first one, we have 1 times 2. We're also going to flip it, 2 times 1. Start off with a smaller number on top. For the last term, 3, we have 1 times 3, and that's it. We don't flip it for the second one. Now we're going to look through, we're going to cross multiply these numbers and see, do we get, or when we add them, do we get that middle number? So 1 times 3, 2 times 1, 2 times 1 is 2, plus 3 times 1 is 3. That does work. That does give us 5. So we didn't have to go and do too much here. What we're going to do then, so these numbers are a pair, and these numbers are a pair in our brackets. We have two brackets. The first pair, 1 and 1, so that means we're going to have 1x plus 1. In our second pair, we're going to have 2x plus 3, and that is our factored form. So this way tends to be a little bit easier when we're going through and doing it. Let's look at the third example. 6x squared minus 7x plus 2. We're going to use this new method for this one, and then we'll do the old method for the next two. But right now, we're going to look for the factors of 6. We're going to start with the smaller number on top. So 1 times 6, 2 times 3. That's it. Now let's reverse them. 6 times 1, 3 times 2. We're going to draw a line. Let's do our last term. 1 times 2. Again, that's it. Now what we're going to do is we're going to go through and cross multiply and see, do we add, or can we add these numbers or get these numbers to the middle term? So 1 times 2, 6 times 1, we get 2 plus 6. That does not work. Let's try our next two numbers. So we move over one each. So 2 times 2, 3 times 1. So we get 4 and 3. Well, that does work if they're negative, and because we have this negative here, that's fine. So negative 4 minus 3, that does work. Even if we were to do negative 2 and negative 6 up top, that wouldn't work. So we'll leave it. So that would still be wrong. So now that we found the two numbers, so that's the 2 and the 1, that's the 3 and the 2. I'm going to create my two brackets. So my two numbers inside is going to be 2x minus 1 because of the negative, and 3x minus 2 for the next bracket. Right, and it's just negatives because of the negative in our number. So let's try the other method, one you might have learned before. So 4x squared plus 27x plus 18. So these two numbers, or these two terms, this trinomial is complex. So what we do is similar to the product and sum. The sum is going to stay the same. We're still looking for two numbers that add to our middle number here of 27. But our product is now going to be the product of 4 times 18 or 72. The 4 times 18 just came from these two numbers here, the first and the last number. So this is where it gets a little bit more challenging, trying to think of what these two numbers are, because what two numbers multiply to give us 72? Well, we have 72 and 1. We have 36 and 2. We have 3 and 24. Okay, that one actually didn't take too long. We do have our numbers. I'm just going to keep it color-coded with what we did before. I'll use red. So the first one didn't work. The second one didn't work. The third one does work because 3 plus 24 does equal 7. So that does work, or 27. So 3 times 24 is 72. 3 plus 24 is 27. Now what we do, we don't just take those two numbers and put them into brackets. What we do now is we take the 4x squared. We're going to split up this middle number into those two terms that we just came up with. So 27x can be split up into 3x and plus 24x. You might ask, well, does it matter which one goes where? No, in this case, it does not. You could put them in either spot. It will still work out in the end. Now what you're doing is you are going to factor or common factor the first two terms and the last two terms. So if I look at the first term, I have 4x squared plus 3x. The only thing that's common between those two is an x. So 4x plus 3 is the first bracket, or is the first common factor. In the second one, I can factor out a 6, or a positive 6, which is 4x plus 3 is what's left over as well. The goal here is to get the same bracket. So we see we have 4x plus 3 and 4x plus 3. So now I can common factor out 4x plus 3. And the remainder, x plus 6, is going to be what my two terms are, or my two brackets is what they're going to be. Save that. Just a lot of color coding. So that's the other method. You're kind of factoring by like decomposition or breaking apart, and then you're factoring by grouping. So a little bit more work goes into that. So if you learn kind of the steps or the patterns for the first one, it does work out. It does tend to be a little bit less work, less steps. You're just finding and looking for patterns. So either way you choose is up to you. We'll leave the last two. So try to factor the last two. Choose whichever method you wish. We do have a lot of space, so I will go through. So I'm going to let you pause the video and try these on your own. We'll come back with both ways of factoring. So we'll see both methods, and again, you get to choose which one you would like. So looking at 5 and 6, these ones are a little bit more challenging to try with the alternative or the newer method, just because of the different signs that we're dealing with. So you do have to kind of play around with what the values are. But the nice thing is, if the first and last number are positive, then your two numbers in the middle should be negative. If the first one's positive and the last one's negative, then you should have one of each. So if you kind of you can take a look at the two examples, the two different methods. Essentially, you're kind of doing similar things, it's just different ways to go about it. So again, whichever way you are comfortable with is fine. You might prefer the product in some method because that's what you're comfortable with. That's what you've learned in the past. And again, that's also what we do with the simple trinomials. So you're just kind of extending that. But the main thing from this lesson is just working through and just being able to factor the different types of quadratic functions, or just factor in general, which we're going to use later to solve some of these equations as well.